Hello, class. Welcome to Pathophysiology. I look at the class list. I know at least 20 out of the 30 of you, and a lot of you had me for anatomy physiology, and some of you I don't know yet. I'm going to be teaching this all online. It's at your own pace. You can listen to the lectures and do the quizzes at your own pace, and then you'll see the exams. They'll be at certain times. You'll need to come and take the exams, but yeah, everything's going to be there for you. Been organizing. You need to go to the Brightspace page for this class, and then you begin. And it's Tuesday right now, and the class starts next week, next Monday. And not sure on your end what it looks like as you register, but so no, I don't. That's the only little piece I'm missing. But I want to get this recorded. Give you guys a heads up of what we're going to be doing, how this is going to work. So shortish lecture here just to introduce some things and get you guys started. So here, this. All right, here we are. So this is doing it online. I mean, I prefer see you guys face to face, but this began. It's supposed to be my 5th year teaching in the summer. When I was first asked because of COVID, it needed to be online, and then but now it's it's nicely organized. I have a lot of lectures recorded, ready for you. A couple of them I'm gonna do some updates on that, but have you guys give you all the tools you need to do well and learn this really interesting stuff. Pathophysiology as a class. I mean, we're looking at all the diseases, all the parts of your body. It's great stuff. So I hope you get as excited about it as I am. So today's lecture, I think it's important that you know who I am, where I'm coming from. I'll be able to Zoom with you guys or talk, or you can email anytime, of course. I'm available, and I'll have office hours, Tuesday afternoon, yeah, or I'll make sure I'm available. But honestly, I mean, you just get message me 2 in the morning, something like that. It's fine. And I can look on the phone. I can be able to answer questions like that, and we can Zoom or meet in person if you're around Portland. So yes, talk about myself, get that done. Look at big picture, and then the mechanics of the class, and then just a little bit get you going, and then that'll be it. And then, as you'll see, you'll start with the first lecture, the first chapter. It's a great book here. So let's see, we'll be reading this in 6 weeks. You guys will be looking at this. Real nice. I suspect most or all of you will have the ebook version, but there's a paper version out there. But you guys will be intimately familiar with all these chapters soon. All right, so I have been at uni, I think 11 years, something like that. And my background, I'm an evolutionary biologist. I study tropical frogs, reptiles, amphibians are really my thing. And but I've been teaching so many human-oriented courses, gross anatomy for a decade, and histology, and mainly at uni, I teach anatomy physiology every semester. I've been doing that. So my wife Lindsay down in the corner, and she is a clinical pharmacist, works at Midcoast Hospital up in Brunswick, a little bit at Portsmouth Regional Hospital. But through her, I know a lot of pharmacy, talk to a lot of pharmacists and providers and nurses and physical therapists and these kind of people. I know, the background of what's going on in hospitals. I personally like to hunt and fish. I'll be a motorcycle, I got a boat, I go mushroom foraging. So I'll be outdoors. I'm also teaching nurse and anesthesiologists this summer too, in person, Tuesday mornings. So it's gonna be advanced anatomy physiology, and they're all registered nurses, and they're coming back to get a doctorate. And so excited, a little frightened, and excited to get going teaching that class for the first time too. Yeah, there we go. I have a cat. I live in Scarborough. to me. Any questions, of course, you can ask me. And we have part of this is going to have a discussion boards, one per week. First week I'll have two. One of them you need to like just tell me a little about yourself, and I just threw some pictures on there of me and went into it some more because you're going to spend a lot of time listening to me. Some of you already have spent a year of listening to me, but for those that not, I love teaching, love students, I think it's important to realize I'm here to help you. I'm enthusiastic, excited about this stuff. And, you can read this on your own. I guess technically you don't have to listen to any lectures if you just want to take the test, but I really, I do it for a reason. I suggest that it's going to be helpful, take notes as you will, make Quizlets. I'm going to have the publisher has flashcards available for you. Indeed. We'll talk a little more about the nuts and bolts of it. All right. So yeah, I'll just show you a few pictures. This is chicken of the woods. It's delicious. It does taste like chicken actually. But my mushroom foraging, UNE, there's a UNE club, the fun guys that we started last year. I'm the advisor to. So yeah, nice days. I'll be taking hikes in woods and so much to learn. So many different kinds out there. It's a whole bag of hedgehogs. Don't eat these. These are jack-o'-lanterns. They glow in the dark, actually, but they're also will make you sick. There's my baby. Again, I have no kids, but I got my Bronco. And I should just say, just earlier this week, I went out. I taught a class on the Galapagos Islands, and we didn't get to travel because Ecuador has some serious safety issues this year, but we did go out to 3 islands in Saco Bay. It's a stage island here. We did intensive biological surveys of these. That's pretty cool. When I was in college, I thought, oh, I'll be pre-med. That sounds good. I went with biology because, again, I spent time in the woods with my grandpa, and I liked biology. I like life. But turns out not really, helping people in terms of, sick people, et cetera. So and well, organic chemistry, I wasn't a fan. But anyway, I did end up getting a Bachelor of Arts in Science. And then I went on to get my master's at Illinois State. And then I was a teaching assistant and I got into research. Then I knew what I was doing. And I went to a PhD program at University of Kansas. Great basketball team, almost always, but I study herpetology. So these are preserved frogs, and I'll be teaching the class just on herpetology, salamanders and frogs and turtles and snakes. Next spring, I'll teach it for the first time at UNE. And yeah, I'm also on the board of directors of Maine Big Nights, which go out in the spring, volunteers all across the state, and you adopt a segment of road where those salamanders and frogs in early March and April, it's just finishing up now, will be crossing that road on rainy nights to breed. And we have volunteers help them across the road and collect data. And so I'm pretty involved in that. All right, so if you look at some classes I've taught before, again, in graduate school, I started in the cadaver lab. For a long time, I taught gross anatomy, comparative anatomy, looking at like evolutionary basis, looking at birds and fish. And so, as I mentioned, pathophysiology and A&P, I'll talk about how well, birds have a more efficient respiratory system than we do, and why our jaws are too small to hold our wisdom teeth, and a lot of we can't look at people like in a vacuum. We have a history, we have relatives, and our body systems are the product of evolution. But again, as you'd expect, this herpetology, we go out trap turtles, we go find snakes and salamanders, and then ecology and conservation biology I'm big into. And here at UNE, last spring break, went to Costa Rica with a colleague of mine, brought students to look at tropical biology, and was hoping to be in the Galapagos now, really, but that didn't work out. But hopefully it will year after next. But as you can see, I've taken students all around the world, mostly tropical places, to look at, to study biology. Yeah, and I get as excited again teaching about snakes and as teaching about the digestive system or anything. It's just, yeah, it's just fascinating, biology. And I always learn this class. I always learn more. You guys ask questions, and there's so many rabbit holes you can go down when you're looking at all the body systems and all those diseases. And we're just gonna, you know, we cover the major ones, but so many. Someone that has this genetic disease, and I get interested and go down that direction. So could spend obviously a lifetime studying pathology, and of course I teach the basics of evolution and ecology and behavior, things like that too. Yeah. All right. So basically, we look at anatomy. You can go down to the microscopic level and histology. So there's a lab manual I wrote, taught histology as just as the class, a lot of looking in the microscope, as you can imagine. And then gross anatomy, of course, it's not gross, it kind of smells gross sometimes, but you're looking at things you can see with your own eye. And you guys recognize this organ. I show these slides, some of you way back when I started A&P, but so it might be familiar, but this is a liver. It's got cirrhosis on it. Those bumps are not normal. This is another liver that is cancer. It has, it's filled with these big white tumors. And we'll talk about these neoplasms. It's a disease, but it's not external. It's not a pathogen that you catch. It's your own genetics where you have changes in the DNA. The cells don't control their growth. And in this case, it's nothing toxic or any kind of exotic disease that kills you. It's just that your own cells, the useless mutated ones, take over the healthy liver tissue, and eventually liver function declines, and then you're going to start showing symptoms. Yeah, A&P. There's at uni, there's anatomy physiology, pathophysiology, which includes it. And a lot of you took anatomy physiology, and then here's pathophysiology, which is where we had just mentioned diseases, because in each group, because this is fascinating, now we get to just focus on it. And I can't review anatomy physiology all over again, as well as teach new materials. So I'll assume you guys paid attention. If not, you can always kind of go back and kidney tubules, I don't remember that. You can review that. I've even got YouTube videos if you want to see me, but you can, look anywhere to find the information if you need to get there. And anatomy, your structure, whether microscopic or gross anatomy, and physiology, the function. So we're looking at how these things work. And in terms of why, we need new textbooks, which is progressing more rapidly. Our knowledge of physiology. Not a lot of new bones being discovered, new muscles, but we learn a lot more. As we look at the genetics, look at the proteomes, we look at the how all these chemical reactions are happening in our bodies. So yeah, pathology is an abnormal state, really. A disease, and this is all lecture 1, but you'll take a look at that. It's the opposite of ease. Everything is fine. So there's going to be an issue. And there are changes in our bodies that happen that are normal, like puberty or pregnancy, things like that. But we're talking about changes in your body's structure and function that is going to cause deleterious issues. Right? Could be something that's relatively benign to something that's fatal, rapidly fatal. So we'll look at that. And the pathogenesis, so we look at how disease progresses. Pathophysiology, looking at these changes that occur with disease. Yeah. And again, I'd be remiss, those of you that have had me before know I'm going to talk about, if you look at the human body as we begin, looking at all the issues, and if you're looking for it to be perfection, as it was designed, everything, look at, the human eye, the heart, it's so perfectly designed. No, you're going to be disappointed. You're going to see right away that we are put together and we work it's amazing. And it is, the eye is amazing. All parts of even our chemistry is just absolutely incredible, but it's not perfect. We are the products of our evolution. We are an animal. We're actually primates. We're a hairless primate with large brains. We got some great technology. We're able to change the climate of the earth. So yeah, we're kind of a big deal, right? As one of the animals on Earth, but we are just, we're just one branch of all of the millions of species on Earth. And for instance, you look at, in humans, all the back issues, people like 80% of people have back issues and that they seek treatment for, and that's a huge amount, right? And if you can't just design a person from scratch. We had an ancestor, much like, cats and dogs and deer that are on four limbs, right? Well, you put us up on, here's a foot, and here's our backbone, here's our head. You put us on walking erect, well, you'd want that backbone to be in the middle, balance the weight on either side. But we're far from that, right? Here's our back. Our weight is in the front, right? So that puts a lot of pressure on that back. And so that's why we see that. And don't get me started, the knees. Again, if you look at the femur and the tibia and on a skeleton, how is that staying together? You all know you got cruciate ligaments and you got muscles that help that. But we have lots of problems with our knees and our back because of our history. And we end up walking upright, and you're not going to get perfection like that. And really what it is we have made small changes throughout evolutionary history. And ideally, if you're going to, make a human, you start from scratch with a blueprint, and just like you would make an airplane or a blender or something like that, but we can't. When evolution happens, it's like fixing your car, but you can never turn it off, because turning it off is extinction. So you need to tinker with it while it's running. And so that's it. So we have things, looking at our appendix and our small jaws for the teeth that don't fit, even chemical reactions that don't seem to make sense. It seems to be like the long way around. But the key is it works. It works. We leave babies, and that's all that evolution is about numbers. And so we go on and leave our genes, and our species survives because we can adapt to this habitat and we're good. But again, I just got to say, if you're looking for, that doesn't make sense. Well, you can look back in time and say, okay, that's where it all comes from, and that we weren't made from scratch, that we are changing slowly over time. All right, I hope you get the idea there. And for those of you that took my A&P, remember from a year ago, I use this example of you look at your keyboard on your, say, typewriter, but on your computer, your phone, it looks like this. The top row is QWERTY. It's your typical, anywhere in the world. Go to Mongolia, to a internet cafe, you go to Ecuador, same thing. Well, you think, well, it must be the most efficient configuration, right? And most people are right-handed. The home row is this middle row. This is probably the letters you use the most. And then the ones you use the least is probably your pinkies, on your left hand, right? You don't use that as that much. Someone obviously came up with this. That's made it the most efficient, the best, the fastest typing. Your fingers have to move the less for whatever language you're looking at. Well, you're wrong. Just like the human's not perfect, this keyboard was actually invented to purposely slow you down, because the first time you use this was these typewriter salesmen in the 1800s. And if you go too fast, the letters would stick. You'd have to stop, pull it back, and it'd look bad and it would take time, right? So it's purposely made so that TH don't stick together like that. And since then, efficiency experts in the 1930s came up with this keyboard, which is much better and much more efficient. Look at those letters in the home row, right? That seems to make more sense, doesn't it? Those are the ones your fingers have to move the least. And you say to yourself, probably, maybe what are you going to talk about, saving 5 minutes over an hour? No, we're talking about, your fingers move 16 miles more in the old QWERTY than this more efficient one. People type all day. There's typists that type all day. So this really adds up. So why don't we go with this Dvorak more efficient keyboard? And you can buy this. You can buy this on eBay, things like that. But what happens? You got to learn it. And man, it's hard to unlearn, when you've been using that original one. So much like us in the metric system, which is just ridiculous, except for scientists, that we use, eighths of an inch, 3/8 of an inch, instead of millimeters and meters and kilometers. All right. So it's that learning hump that we don't want to go over. We don't want to change all our signs from miles per hour to kilometers per hour. It just seems too difficult. We should just rip the Band-Aid off and do it. But same thing with us. We have eyes that work, even though the wiring, if you remember, comes out the front. And so we have blind spots instead of coming out the back. We have all these things that don't seem to be the most efficient, but they work. We survive. We leave babies. And so we continue with that. All right. Just one example, make you think about, looking at human anatomy, physiology, is it perfection? Is it the most efficient? No, but it works. And it's amazing. I can't get over it's amazing, but it didn't just be drawn up with a blueprint. All right, let's get serious. So when you start a new class, the textbook publishers love you, send you everything. So years ago, when I looked at a text, I looked at many texts, and I say, this one seems to hit a sweet spot. Really nice for allied health professionals. If you're looking at a medical school type text, it'd be a thicker one. We would have more time and it just be more in depth. But this gives you a broad coverage and gives you that vocabulary that you're going to need to give you a good basis of this human disease and pathophysiology. All right, so this is the book looks like. It's what you want to do actually with this. Let's see. Oops. Oh, did not like that. Sorry. There we go. What I can tell you is this. Let's you can look up JB Learning. It's Jones and Bartlett is the publisher. But what I'm going to have you do is just, I believe, is go to the Brightspace. When Brightspace opens, so you open Monday, I think it's 8 a.m. And then you can just click on that first chapter and it will take you where it's going to ask you, do you have a code? Do you want to buy the book now? And then you'll be able to get into our, so that's going to set it up to get the textbook originally. So that's, I believe, we're going to do. I'll send out, of course, an email the first day to make sure that you all have exactly what you need to do. I'll come back to it in a moment here, but this is take a look overall what we're going to cover. And so as you can see, we have 6 weeks. And then this is the first week right here. And so this class, you got to be self-motivated. I'm going to, every week, I'll send you an email. This is what you need to do that week. And these deadlines of these quizzes, I'm not going to don't say, oh, I had something came up or I was sick. And these deadlines, beginning of class. And so I'm not going to, if you miss it, you miss it. So what's going to happen. And the exams are going to be, again, I do it through a Sunday and a Monday. For those that, are not available on the weekend, take it on Monday, Sunday. And so you'll go in when you get a nice place where you feel comfortable and quiet and you have the time. It'll be timed. And questions will be ordered to be a lockdown browser. It's going to have you. And again, I would hope you wouldn't cheat as a college student. You are some of this, of course, it's it's up to your own ethical and moral standards, and I don't know all you that well, but this is, you're learning this for you. Big picture. You're not pleasing me. I guess you just want to check off a box. I mean, hopefully this is something you want to learn for anyone in athletics or nursing or dental hygiene. These are things that it's important and interesting to learn. And so I guess I'll just say that at this point is that you'd hope you come out of this not just wasting your time. You actually come out of it with all this in your head, having to learn this. So I'm here, to help you, to guide you, to inspire you. But you guys are putting in the work. You're going to read these chapters. For instance, the first week, chapter 1 through 4. Each chapter has a quick quiz, either between 5 and 10 multiple choice true false questions that you'll do over that. So read the chapter. When you feel good about it, do that quiz. It's on Brightspace. You do that quiz. You got one chance, timed, and then that'll be great for that. So you can see there's going to be 30 quizzes, 30 chapters. And then we'll have 3 exams every 2 weeks. That's Sunday, Monday, sometime in that time period. Brightspace, you can take that exam. I'll put a practice exam also on there. And I'll remind you guys to take it to make sure your computer is all set for that Brightspace lockdown browser. You have to close everything else. And so you've tested it, so you're ready to go. And that practice test, practice questions, you can take it as if it's the real one so that you feel comfortable what it's going to look like, how you're going to log in, and then you'll be set. All right. And then basically looking at the course, again, I don't want to talk too long, but I'm giving you the whole thing here, is that really 3 sections. And first, we'll talk about pretty much what is pathology, and a lot of terminology, a lot of vocabulary. So got to get this done. You got to know what we're talking about, what a pathologist is, all the different types, what a symptom versus a sign is, and medically, a CT scan, MRI, diagnostic type things that are used in healthcare. I'll talk about the significant diseases. What are killing people? There's all kinds of weird, rare diseases out there. It's only found in, southern Somalia or something. We spend a lot of time on that one, but diabetes, AFib, things like that, we'll spend more time. Yeah. And then there's a section here where we're going to talk, this is real important stuff, talking about disease in general, looking at, is disease something exogenous, like is it a pathogen, or is it within you, like a cancer or high blood pressure or hormonal issues in your own body. So we'll look at that, and genetic diseases, and neoplasia is cancers kind of thing. So yeah, we're going to set it up with these real important topics. And then for the first test, we'll start with looking at some heart issues and some blood pressure, vascular type issues. So the first 2 sections, and the rest of the class is going to be going through all these systems, and from the eye to the breast to muscles to bones to kidneys to gallbladder to all these things. We're going to look at the major issues with all of these. Again, I'll briefly talk about normal physiology, and then so we can jump right into the major issues. And the ones at the end, including even mental issues and nutritional disorders. We'll talk about some diseases that maybe affect several systems at once. And so take a gander, take a look at the list here, see what you think. Yeah, covering it, everything. Look at that. Much fast-paced. Every 2 weeks, an exam. And so you guys, like I said, I won't say it again. You need to look at the calendar feature of Brightspace and put it in your own calendar, write a piece of paper, set your alarm, I don't care, so that you are done with the quizzes on time, follow along, and you take that exam, and we move on. And so again, cramming is just such a bad idea, just impossible here. You've got to just take time every week. Again, this is all compressed into 6 weeks. So taking a class over 6 weeks, you need to just make it a regular routine. And again, since you can do this, you can listen to me anytime, you can read anytime, at the beach, at work, depending on what your work is, 2 in the morning, maybe you're a morning person, 8 in the morning, whatever you want to do. But you're not going to be in class, I'm not going to be there watching you. So again, you don't realize, oh, it's been a week and a half, I better study all 8 chapters. That's just not going to work for you. I'll tell you that, you guys are adults, you're on your own, but I'm going to keep you going. I'm not going to open up the whole course either in the beginning. I'll keep you guys moving along at the proper pace. The grade, you're going to see there's no lab, there's no lab reports, there's no written homework, there's no essays, anything like that. The 3 exams are the bulk of the material. And again, I'll have a practice exam. You'll find in the book, there's practice questions after every chapter. And then I'll post, you'll see on there the answers, because the answers aren't in the book, but I'll give them to you. So you can use those questions, you do them first, and then you can go back and you see, oh, did I get it right or not, and why. Every chapter, you're going to see at the end, you take a quiz. And then I'm having some discussion boards. And so this is a little more free free flowing, a little more interaction, because again, not much interaction because I can't see you guys. So the first day, you're going to see the first one is you're going to like just say hello, say a little bit about, what your major is, something like that. So points for that. All right. Just do that. And also I'll be able to see, I got a picture on there, not required, but be good if I can see who you are. I can look back and say, okay, that's who that is. And this is about them. So, I get a sense and yeah. And then we'll have, I'll think of discussions for each week. So there'll be 6. So 7, 2 the first week and then 1 each. So there'll be 7 little discussion boards. And I'm just going to grade you if you have an intelligent answer discussion. You can, piggyback on other people's, but, you need to, when it'll be due, closed, and then I will look and I will see if you forgot to do it, you get 0. And if you did it, you get your points. So, all right. All right, and again, I'll give you more than nuts and bolts, but in case we need a course code, I put it in this. This is the course code in this PowerPoint. But again, I'll give you another email just how you get in there. I think I've talked about strategies, what not to do anyway. All right, just a few slides here. I guess just again, big picture, you realize that if you remember talking about the history of anatomy, Galen, he was the physician of the gladiators, and he had all these mistakes, because he dissected apes. He couldn't really use humans too much in that time, so he had all these mistakes. But it was like the Bible, and people used Galen for 1,000 years. It's easy to throw those numbers around, but think about that time frame. How many generations? And when someone would find something that didn't fit Galen, it must be my fault, because Galen is the Bible. He can't be wrong. And finally, in 1500s, Vesalius, he's like only 26 years old. He wrote this De Humanae Corporis Fabrica, the human, fabric of the human body, and put us on on the correct path of using evidence of actually dissecting humans and not reading tea leaves or looking at chicken entrails, but having our modern medicine, which I'll talk a lot in the first lecture, evidence-based modern medicine. And again, not everyone follows that. There's all kinds of weird crap out there, right? But let's leave it at that for now. Beautiful. It was a painting by Rembrandt. Great dissection. Yeah. And today, all of you have resources that were unimaginable. Even when I was in college, you have Quizlets online, you have the Visible Human Project, you have people that have been frozen and put into slices and digitized out there. You can fly through the human body. There's so much out there now. Yeah. And some of this physiology and some of this imaging that we have with MRIs and functional MRIs and things are coming up all the time. Instead of lie detectors, looking at your sweat and your heart rate, now we'll be able to look at the brain and see what parts light up, and to see if you're telling the truth. But the point I want to mention here, of course, is that we're going to look at human disease, in a scientific basis, based on evidence. All right, and actually, if you think about it, you think, our knowledge is increasing exponentially, right? And it is because we keep learning more, and since we can write things down with the internet, people can build on that, stand on the shoulders of giants, right? But really, if you look at how our knowledge is being accumulated, it's more like this. And what we have here is times of a very rapid, a lot of discoveries, and then less discoveries. And what happens in these points here, these inflection points here, is that a new technology or a new idea comes about. So with a microscope, then all of a sudden we could see cells. And then the electron microscope, we could see even more. And the idea in here, evolution, this concept allowed us everything else to make sense, and things really progressed. So these are generally when we get new technologies that are always coming out to allow us to see deeper and deeper, and with supercomputers, be able to look at all the chemical reactions going on simultaneously that we could never do on paper. And so, yeah. Yeah, so we're going to go through all these, and you're going to be kind of surprised that we spent so much time with bones and muscles in the nervous system in A&P. In terms of disease, muscles and bones. There's not that many. There's a lot more things that can go wrong with your glands and your heart and your lungs and your kidneys. But we spend so much time, memorizing all these muscles and bones, which is important, but we'll see a little bit of asymmetry in how disease affects these different systems, right? But skin, oh yeah, we're going to talk about with the names of these lesions and warts and things like that. And, yeah, some muscle diseases and osteoporosis here. We'll look at mental issues as well as MS and demyelinated diseases and things like that. A lot of endocrine issues. Remember Cushing's disease, Addison's disease, hypothyroidism, all these things like that. And of course, big killer is your heart and cardiovascular system and atherosclerosis. Lymphatic, talk about the spleen, I guess. Yeah, we'll talk about spleen. And then I guess elephantitis, you can have blockage in the lymph system and have like enlarged limbs, things like that. All kinds of things, COPD, lung cancer, all kinds of things going on there. Digestive system, indeed, gallbladder issues, Crohn's disease, even dental caries. Yeah. And then, kidneys, glomerulonephritis, talk about a lot of kidney issues, bladder issues, and reproductive. Yeah, we'll do male, female, breasts. We'll look at all the issues that can affect that system as well. All right. And then again, just the big picture here, you're looking at, this is your body, right? And then your heart is pumping blood through all the tissues, and it picks up nutrients and water and vitamins from this digestive tract, which is a tube open on either end, but we can absorb through the capillaries the nutrition that we need. And then it also goes through all these capillaries through the respiratory system in your lungs and picks up the oxygen and dumps off the carbon dioxide. And then it goes through your kidneys, which will filter, and you'll be able to pee out wastes and make sure that your electrolytes and water are just right. Whew. And all of this blood, and it doesn't actually, remember, interact with the cells, but it's close. And the fluid comes out of the capillaries, gets a blood pressure, and it washes over them. So that's the big picture. We have these millions and millions of cells that need to be babied. They got to be kept at the right temperature, the right amount of sodium and calcium and magnesium. Everything's got to be just right. pH has to be between 7.35 and 7.45. They got to have everything just right for them. And that's what all of our bodies, our whole body does. The systems work together to keep all our cells happy and keep us in homeostasis, right? And again, that's kind of the key looking at disease, is when we throw off this homeostasis. This static means, not moving. And so, how we keep our body temperature, our glucose levels, everything, pH, at levels that are acceptable for life. And if you're in the hospital and they do a full panel, they'll, if your calcium is above, it's bright red, it says, oh, you're going to die unless you bring that down, right? Or if it's too low, they got to bring it back up. And so everything like that. And again, I don't need to review this too much, but much like a thermostat in a house, you look at, this could be body temperature. Let's say it's glucose, your blood sugar. So after a big meal, you eat a bunch of candy and carbs, your blood sugar is going to spike, but that will kill you. So you release insulin and you take that glucose and you put it into glycogen, you store it in the liver, muscles, everywhere. But then when you're fasting between meals, your blood sugar drops. And so then you break down that glycogen to glucose, and that brings your blood sugar back up. So this is this idea of homeostasis. There's a receptor, and to be your pancreas is measuring your blood sugar, really. And it will release insulin and glucagon, which will cause changes to keep your blood sugar within that range. It's just an example. And here, looking at your body temperature, you sweat or whatever when you need to do that. So let's keep this in mind. We keep our body in a state of homeostasis. And disease is if something is kicked out of the way, it's going to lead you towards issues in your body and maybe death. All right, and don't forget, we talk about disease. Where does it hurt, right? It's in the right lower quadrant. What do you think? You better think about your appendix. That's possible, yeah. Gallbladder, right upper quadrant. Yeah, yeah. Spleen or stomach here. This could be an ovary, it could be colon, something like that. So anyway, we can describe, look at our belly button, um, make four squares and describe it. And you can even get crazy like this and talk about more regions. So you're talking about, you got a mole in the epigastric region, you got a gunshot wound in the left lumbar, you got pain in the right lumbar. So you can use these terms to describe an issue to someone that cares. And aging as well. Hope you haven't aged too much. This has been too long of a lecture, but spent a lot of time in A&P after every chapter talking about how the body systems change with age. Very few good news stories here, right? We get wiser, but your kidneys, your skin, your teeth, all these things kind of well, how do I say this? They decline in use, and you know, sometimes you don't notice. Like if you, let's say your lung capacity isn't as great as when you were 20, when you're 80, right? But you're not, you're not playing football, or so you may notice if you try to climb stairs or run a marathon, but otherwise you can age and appropriately so that these body systems don't get tested, and even if they decline, it's not gonna, you might not even notice. Indeed. Yeah. Changes with lifestyle, lifespan. Yep. All right, last slide. All right, you guys have been very patient. So you got the plan. You're gonna spend time, you're gonna read chapter 1. We go right in order, and I will release things, at least a week in advance, week and a half in advance, so that you can work at your own pace, do quizzes for each chapter, get ready for that exam, 3 exams every 2 weeks will be an exam, and do those discussion boards. So look on here, see what's due, what do I need to do? And yeah, and all that will go into your grade book in Brightspace. You'll be able to follow along. There's no mystery. You'll be able to see exactly what your percentage is at any time. And you're in control of that grade. I'm not giving you a grade. You are earning the grade by successfully doing these assessments. All right. So content heavy is true. You're not going to be doing like if you were studying, you're taking calculus or physics in summer, you may be doing problems, and doing, figuring out things like that, doing repetition. But this is a lot of content. You're going to learn a lot of vocabulary, a lot of things you need to memorize. So keep that in mind, how you study best. None of you are freshmen. You've all had classes, college classes, and what works for you, hopefully. Whether it's Quizlets, whether it's making a study guide, whether it's listening to lectures or reading or doing both, or whatever works for you. Everything's going to be provided for you, and then you need to get that information into your head so you're ready to answer these questions. And with that, hopefully this will be stored into long-term memory. Study plan, stick to it. Right, have other things going on this summer, but say to yourself, I'm going to spend an hour Monday, Wednesday, Friday. This is just going to be pathophys time. Probably more than that, I guess. You're studying 4 chapters, but so you're going to spend this time and do it for yourself. I mean, just yeah. Now, if you struggled in A&P in a certain system, you may struggle in pathophysiology of that system as well. So feel free to look back at your notes, look back at your book, Google, look at YouTube for information so that you can kind of review, okay, yeah, that's the EKG. So when Parmalee talks about bradycardia, okay, I understand what's going on. And then I can't say this enough, just in general, I see students that want to memorize things, and then they want questions on the test to regurgitate that. That's the lowest level of learning, really. And this is a 300 level class. Pathophysiology, I mean, it's difficult class. It's something. It's the basis for a lot of healthcare. This is the disease, the study of disease, and if you work in healthcare, that's what you're looking at. You're looking at that, and so these things wicked important, and especially early on, get at what it means to what a diagnosis is, what all these terminology is. And you want to learn this material in order to apply it to something novel. I mean, you're not going to get a patient that is going to look in the book and say, "Oh, here's the study guide question I'm going to ask you." No, it's going to be simply completely different. It's going to be completely novel, and you need to use this material that you've learned and apply it to that. So be comfortable looking at a case study and applying things, and not simply what do I have to memorize. But you may look at yourself in bold. There are terms in here that you need to know. And so it's probably helpful to make flashcards or kind of look at those terms. But basically, if you understand something, that's what it's going to really come down to. And I know you're listening to me, but I hope it really gets in your head that that's what you're aiming for here. You want to master this material, which doesn't mean you can regurgitate it like you have a photographic memory, but it means that you have taken the time, you've looked at every chapter and studied it and understand it, and hopefully be inspired and interested in it, because I still read it. So, I've read it many times. It's just good stuff. All right, see my face big again. Don't know how long this took, but it's my introduction, getting you guys ready for this. So we'll do 6 weeks of pathophysiology. Yeah, I'm here for you. I think if you know me, you know that. Just feel free, shoot me an email. Happy to answer questions. We can Zoom if you want. And you guys get that mindset. I'm going to say, okay, I had 6 weeks of my summer at the beginning to get Bio 309, to get it done, and that take this time in the summer to read these and to, it's really interesting stuff, right? All of you are going to be involved in healthcare. You get your loved ones, you're going to come back to this because people get sick, people have injuries. And so this is something that is applicable to all of you. It's not ancient Greek mythology that I shouldn't pick on anything particular, but I'm just saying that you may use those lessons, but this you're gonna, it's sure between you and me for sure. All right, I'll end this now, and I'll be nice to meet you if I haven't met you yet, and look forward to getting to know you, all of you guys.